Hi everyone, today we have properties of matter. Today we'll be discussing the topic thermal stress. So in this scenario today we have a rod of length L0 which is fixed between two walls at a distance L0 from each other, and the entire system is being heated by some delta theta. This positive change in temperature will cause the rod to expand. However, we have the constraint due to the wall. So we'll be talking about the force here, right? So the thermal expansion of the rod is being constrained by the wall with a force F, and we need to find this force F, right? So we'll be involving two properties of matter here. We'll be involving the thermal properties and the mechanical properties, right? So the thermal properties for matter, for which we know that the thermal expansion, the change in length for the thermal expansion we are aware of is the original length times the temperature coefficient. Now for the rod we had, the area of cross section can be assumed to be A, the temperature coefficient can be assumed to be alpha, and the Young's modulus is Y, right? Now the change in length due to the thermal expansion is L0 times alpha times delta theta. The final length of the rod after the expansion has occurred is L0 times 1 plus alpha delta theta, right? So we just added the original length to the first situation, so we got the second equation. Now for the mechanical point of view, we know that the stress will cause some strain in the rod, right? Now the stress will be developed by the force per unit area, which will be causing some change in length, and that can be related to the thermal change in length, right? So the force per unit area has to be the removal of the constant. Here we have the Young's modulus Y times delta L over L. This delta L is the L0 times alpha delta theta over the final length, that is L, is L0 times 1 plus alpha delta theta, right? L0 and L0 cancels away. So we get the value for force F as A Y times alpha delta theta by 1 plus alpha delta theta, right? That is the answer to the question, and that is it for now. Thank you for your time.